Okay, question 1, part A says find dy dx and the values of x for which dy dx equals 0. So first of all, find dy dx. So we do 1 take away 4x, and then we want to find out where that equals 0. Rearrange that equation, so it's this side equals this side. So add 4x to both sides, divide by 4, that gives us x is a quarter. For part B, we want to classify the points on the curve with these x values. So we go x and dy dx in a little table. Our value should be a quarter in the middle, and then two values either side, so it might be useful to do 0 and a half. So that'll be 0, 0.25, 0.5. So we already know that for x equals a quarter, dy dx equals 0. That goes in there. For this one, we do plug this into dy dx, which is 1 take away 4x. We get that from up here. So that's 1 take away 4 lots of a half, 1 take away 2, which is negative 1. For this one here, we do the same thing, dy dx equals 1 take away 4x, the same equation from up here, from before. That's 1 take away 4 lots of 0, that value there coming into here. That's 1 take away 0, which is 1. So we've got a positive value, 0, and a negative value. What that looks like, we get a positive gradient, then we get a 0 gradient, and then we get a negative gradient. Positive, 0, negative. So that is a maximum point. Part C of the question says find the corresponding y values. So we go back to our original equation, our original function. This takes in an x coordinate and produces a y coordinate. So we're going to go y equals 1 plus x take away 2x squared, and so we're going to substitute this value in, equals 1 plus a quarter take away 2 lots of a quarter squared. So it's 1 plus a quarter take away 2 lots of a quarter squared is 1 times 1, which is 1, and 4 times 4, which is 16. 1 plus a quarter take away 2 lots of a 16th, 2 16ths would be an 1/8. A quarter being 2 8ths, 2 8ths take away 1 8th, that's 1/8, so it's 1 plus an 1/8, 1 and an 1/8. And that is the value of y. Question 2. Here's our function. And we know we need to differentiate straight away. And we want to know the maximum and minimum points, so that's where this equals 0. Now this is a quadratic, so I'm going to make it a little bit simpler by dividing everything by 6. I can do that because if I've got an equation now where it equals 0, so if I divide 0 by 6, then this equation stays the same. So 2 plus x take away x squared equals 0. Nothing has happened to this now because I've done everything to every term. Now I don't like this negative x squared, so I'm going to multiply everything by negative 1. That gets negative 2, take away x plus x squared equals 0. And if I just rearrange that so that the x squared appears first, x squared, take away x, take away 2 equals 0. Now, factorise that. So that's going to be x take away 2 and x plus 1. So that means your two solutions are x equals 2 or x equals negative 1. Right, when we are going to find out for part B the nature of those points, we've got a point at negative 1, we've got a point at 2, and those are our x values. We want to work out some gradients in between these points. So that's negative 2, 0, we'll try, and we'll try 3. Now we know that dy dx is 0 on there for this one. Remember that that was one of the solutions to make this 0, and also one of our solutions was 2, so this is 0 as well. Now plug these other values into dy dx. So dy dx is up here. Now we can't plug it into this one because this is our modified equation. It won't give us the same answer. Because remember, this won't equal 0 for these values. It will equal something else. So this one, our dy dx equals 12 plus 6x take away 6x squared. So we're going to do 12 plus 6 lots of negative 2, take away 6 lots of negative 2 squared. 12 take away 12, take away, now this is 6 lots of negative 2 squared. Negative 2 squared is 4, so 6 lots of 4 is 24. 12 take away 12 is 0, take away 24, that's negative 24. This one, dy dx equals 12 plus 6x take away 6x squared. So we do 12 plus 6 lots of 0 take away 6 lots of 0 squared. Now this is a nice easy one because 6 lots of 0 is 0, 6 lots of 0 squared is still 0, so this is going to be just 12. So if you get the option, 0 is a nice one to do in future. This one, dy dx is 12 plus 6x take away 6x squared, 12 plus 6 lots of 3 take away 6 lots of 3 squared, 12 plus 18 take away 6 lots of 3 squared is 9, so 6 lots of 9 is 54. So that's 30 take away 54, which is negative 24. Oh, I've just gone over my error there. So this is negative, this is 0, this is positive, this is 0, and this is negative. So it looks like this, a negative gradient, then we've got a 0 gradient, and then we've got a positive gradient. Negative, 0, positive, that's the first 3 values. And I'll do a separate diagram for the next 3 values, these 3. So first of all we start with a positive, then we go with a 0, and then we deal with a negative. Positive 12, 0, negative 24, that's those diagrams, those directions. So this is a minimum, and this is a maximum. Now all we need to do for part C is to find the respective y coordinates. So we're going back up here. X is 2 and x is negative 3. We've got 2 x values, so we're going to get 2 y values. So if x equals 2. Right, we need something that's going to tell you what our y value is. So we want y equals something. Now that's all the way back at the very beginning. It's this thing here. This takes an x coordinate and spits out a y coordinate. So it was 12x plus 3x squared, take away 2x cubed. So that's 12 lots of 2 plus 3 lots of 2 squared, take away 2 lots of 2 cubed. 24, 3 lots of 2 squared, that's 3 lots of 4, that's 12. 2 cubed is 8, 2 lots of 8 is 16. So that is in total 20. So your coordinate for that point is 220. For this one, if x equals, now we had 2 as a value from up here, so x is negative 1 now. So y equals 12x plus 3x squared, take away 2x cubed, equals 12 lots of negative 1 plus 3 lots of negative 1 squared, take away 2 lots of negative 1 cubed. 12 lots of negative 1, negative 12. Negative 1 squared is 1, so 1 times 3 is 3. Negative 1 cubed is negative 1, so negative 2 times negative 1 is 2, so it's going to be plus 2 there. So that's negative 12 plus 5 basically, so that is going to be negative 7. So your two solutions are negative 1, negative 7. Question 3. First of all, differentiate. 3x squared, take away 8x, and we set that equal to 0. This is a question where I can factorise. It's not one with double brackets, otherwise it would have a constant at the end. So we know that x is a common factor. 3x take away 8 in the brackets there. So our two solutions to that, either the thing at the front can be 0, or 3x could equal 8, and that will be 8 take away 8 would be 0. So if 3x equals 8, then x equals 8 thirds. I'll just show you how you do that, just in case that is causing you any problems. If we want that bracket to equal 0, 3x equals 8, x equals 8 thirds. Right, we need to find our values surrounding those two bits. So we've got a 0. 8 thirds is 2 and 2 thirds. So I'm probably going to go with 1. I'll go with negative 1 there. 8 thirds, and we'll go for a number above. We'll go for 3. So we already know that this gives us a dy dx of 0, this gives us a dy dx of 0. Let's plug these numbers in. So plug that into that formula. You can also plug it into this formula. So dy dx equals 3x squared take away 8x, which is 3 lots of 3 squared take away 8 lots of 3. That's 27, take away 24, which is 3. That's a positive 3. This one, dy dx, which is 3x squared, take away 8x, is 3 lots of 1 squared, take away 8 lots of 1, which is 3 lots of 1, 3, take away 8, which is negative 5. And this one, dy dx, 3x squared, take away 8x, 3 lots of negative 1 squared, take away 8 lots of negative 1, 3 plus 8, the negative 8 times negative 1 is positive 8, so that's 11, so that's a positive. So if we were to draw this, the first three values, we've got a positive, a 0, and then a negative. So positive, 0, negative. So that is a maximum. And the second three values, we've got a negative, a 0, and a positive. A negative, a 0, and a positive. So that is a minimum. Now we need to find out some y values to go with it. Let's go back to our function way at the very beginning. Y equals x cubed, take away 4x squared plus 9. So we're going to substitute in our values of x. Remember, our values of x were 0 or 8/3. So we're going to go 0 cubed, take away 4 lots of 0 squared, plus 9, so that is just equal to 9. So our first coordinate will be 0, 9. Our other coordinate, we use the same function for, but this time we plug it in as 8/3. Now, I would keep this 8/3 like this. I know I've used 2 and 2/3 when I was drawing this table, but it really helps leaving it as a top heavy fraction for when you're putting it into a function. So I'll show you that now. So we just substitute it in. Now, I can of course do this on a calculator, but if I want to do 8 cubed, I can just do 8 times 8 times 8, 3 cubed. I can do 3 times 3 times 3. It's dead simple. This one here, 8 squared is 64, 3 squared is 9. It just means that I can do this without using a calculator if I choose. Right, I'm going to multiply this by 3, so 768 over 27, the top and the bottom, so we've got the same denominator. So that is negative 256 over 27 plus 9. Convert that into a mixed number now, and then you've got negative 13 over 27. So your final answer is your x value was 8/3 and your y value is negative 13 over 27. Question 4. Right, this is in a little bit of a nasty form for differentiation, so what I'm going to do first is expand this. And then use FOIL on this. And then finally multiply x squared by everything in here. So that's x to the 4, take away 2x cubed plus x squared. Now I can differentiate that. Right, we want to find out where that equals 0. Right, this unfortunately is a cubic, so we've got to find a factor where this comes out as 0 to begin with. So I'm going to try 4 lots of 1 cubed, take away 6 lots of 1 squared, plus 2 lots of 1. So that is 4 take away 6 plus 2. 4 take away 6, negative 2 plus 2 is 0. So we know that 1 is 1 gives us a value of 0. So x take away 1 must be a factor. So there's several ways that we can find out the remaining factors. I'm going to use my favourite, which is to find the quadratic that you have to multiply by that. So if I multiply this out, group all the x cubed terms together and the x squared terms together, so I'm just bringing these two together to be next to each other. All the x terms together and then the constant at the end. So I've got ax cubed plus b take away a lots of x squared. That's b take away a lots of x squared plus c take away b lots of x take away c. Right, we know that the a, looking back at our original expression, we know that the a must be 4. So we can plug that in. A equals 4 there. The b take away a is the number of x squared, so that's negative 6. So we already know that a is 4, so b take away 4 is negative 6, so b is negative 2. And the c take away b, which is the number of x, must be 2. We already know b is negative 2. C take away negative 2 is 2. Taking away negative is the same as adding. Take away 2 from both sides. And sure enough, C equals 0. And of course C equals 0 because there's no constant up here. So this minus C here is meaningless. So you're going back to this equation here, we can say that instead of x take away 1 ax squared plus bx plus c, we've got x take away 1 4x squared plus, take away 2x. The plus c, I haven't added 0, so that's what we're left with. Now this isn't a quadratic, so we just take out a common factor. The common factor, it looks like 2x goes into both. So I'll put that at the beginning. This thing here, x take away 1. 2x times 2x is 4x squared, and 2x times negative 1 is negative 2x. So the big problem on that part of the question was that you had to factorise a cubic, and that was from an earlier topic in this course. Right, your three values then that will give you a solution of 0 are if x is 0, that would make that 0, or if x was 1, that would make that 0. And on this one, 2x take away 1 is 0, that means that 2x is 1 and x is a half. Three values where we've got zeros. Okay, onto a new sheet here. So x and dy dx in our table. Right, so your values are 0, half and 1 in that order. And we need values to the left and to the right of them. So I'm going to put a value there, a value there. This is where a half is going to go, and a value to the right of it. This is going to, where 1 is going to go, and a value to the right of it. So we know all of these values are zeros. These other values are things in between. So we'll call that 2, we'll call that 3/4, we'll call that a quarter, and we'll call that -1. I'm trying to pick whole numbers where I can to make it a little bit easier. Now, I'll remind you that dy dx from earlier on we worked out was 4x cubed, take away 6x squared plus 2x. So we're going to plug in these values into here. So if I plug in -1, that's going to be -12. Let's make this actually look a bit more like a table. Right, if I plug in a quarter, now at this point you might like to call a quarter 0.25 and work it out using a calculator. That's perfectly fine, unless of course it appears on a non-calculator paper, but you can take the time to do it then properly, can't you? This will be 6/16 plus a half, so 4/64. Let's convert them all into 64ths. So that is -20/64 plus 12, so that is 12/64. Now it doesn't actually really matter what the value is, just that you know it's positive. So I suppose I could stop here really. It's 3/16 is the answer. And the fact is that it's positive, so as soon as I realised that was going to be positive, at whatever point I realised it, that would have been fine. So I'm going to try 3/4 now. And again, you can use 0.75. And on the next question I might do that to make it a little bit simpler. Right, everything in the denominator of 16ths. So -27/16 plus 24/16, that's -3/16. And again, it's a negative. That's the most important thing. Notice the symmetry here. I suppose we're a similar distance away, aren't we? Well, we're the same distance away from the half. Now we'll try the 2, and I'm going to go dy dx equals 4 lots of 2 cubed, take away 6 lots of 2 squared, plus 2 lots of 2. 32 take away 24 is 8 plus 4 is 12. So it's positive. So we have got a negative, a 0, a positive, a 0, a negative, and a negative, a 0, a positive. There seems to be a pattern here. So first of all, let's deal with these first three. Negative, 0, positive. Negative, 0, positive. Negative, 0, positive. So that is a minimum. Next three, positive, 0, negative. Positive, 0, negative. That's a maximum. And last three, negative, 0, positive. That's a minimum. Now to find out my three coordinates. Remember, my three x values from before were x equals 0, x equals a half, or x equals 2. 1. That's those three coordinates there where the value is 0. Or should I say those three x values. Right, we plugged that into our equation that is for generating values of y. So I'm going to plug it into this one here. X squared, x take away 1 squared. So now I could have plugged it into my expanded equation, but frankly that one was more complicated and this one works just as well. And you can see I don't even need to work out negative 1 squared because I'm going to be multiplying it by 0, so it's just going to be 0. So one of our solutions is 0, 0. Another solution is going to be a half, so y equals a half squared, a half take away 1 squared, so that's a quarter. Half take away 1 is negative a half. Negative half squared is a quarter as well, so it's a quarter times a quarter, which is the 16th. So it's going to be 0, 1/16. Oh, sorry, half, 1/16. And finally, x equals 1, y equals 1 squared, 1 take away 1 squared. Now 1 take away 1 squared is 0 squared, isn't it? So this is going to be 0 as well. So it's going to be 1, 0. Now to sketch the graph, we know that the turning points are going to be 0, 0, half, 16, and 1, 0. So we've got a minimum there. So if I was to draw some axes real quick. So at 0, 0 we have a minimum, so we know we're going to have something that looks like that. At half 16 we are going to have a maximum, so I'll call that point there a half. And it is going to peak like that. And at 1, 0, we are going to have a minimum again. So it's going to look something like that. Something like that. There's the minimum, there's the maximum, and there's the minimum again. Now we need to label these coordinates, so that is going to be 0, 0, That is going to be your 1/2/16, and that is going to be your 1/0. Number 5. So we're going to differentiate and set that to 0. We're then going to take a factor out. So we've got 4x as the common factor. X squared, take away 4. Okay, so x can equal 0. Now this is a cubic, so you'd expect there to be 3 solutions. X squared take away 4, or should I say up to 3 solutions. X squared take away 4, so x squared take away 4 equals 0, x squared equals 4. Now remember, there are 2 solutions to a square root, so it is plus or minus 2 are your answers. So we have 3 answers: 0, -2 and 2. So let's find the nature of these stationary points. So we've got -2, and we need a number to the left of it, so we're going to have -3, -1 and 0. So this is your 0 value, this is a 0 value. We'll try 1, 2 and 3. Now this is your final 0 value. So we've got +2, -2, and we've got 0 as well. Right, we'll work out these values here. So we plug these into dy dx. So dy dx, 4 lots of -3 cubed, take away 16 lots of -3. So that'll be 4 lots of -27 plus 48. Now I can already see this is going to be negative. I know 4 lots of -27, what's that? -108. It's going to be much bigger than our 48, and the point is that we know that this is positive or negative. That's the most important thing. So that's a -60. This here, this -1, dy dx equals 4 lots of -1 cubed, take away 16 lots of -1. 4 lots of -1 cubed, -1 cubed is -1, so that's -4 plus 16, so that is plus 12. 1 cubed, 4 lots of 1 cubed there, take away 16 lots of 1, so that is 4 take away 16, which is -12. And this one here, dy dx, is 4 lots of 3 cubed, take away 16 lots of 3. 4 lots of 27 is 108, take away 48, and we're back at 60. So the first 3 points, we've got a negative, a 0 and a positive. Negative, 0, positive. So that is a minimum point for -2. Second 3 points, positive, 0, negative. Positive, 0, negative. So that's a maximum point. And last 3 points, -0, positive, so that is going to be -0, positive, minimum. So now we need to find our 3 coordinates. So we've got x equals -2 for this one, x equals 0 for this one, x equals 2 for this one. So we want to go back to our original equation. Y equals x to the power 4, take away 8x squared plus 4. So that's negative 2 to the power 4, take away 8 lots of negative 2 squared plus 4. This is going to be 16. Take away 8 lots of 4, take away 32 plus 4. That's negative 16 plus 4, that's negative 12. First coordinate then, negative 2, 12. This one, 0 to the power 4, take away 8 lots of 0 squared plus 4, so that is 4. So your second coordinate is 0, 4. And your last one, take away 8 lots of 4, that's 32, plus 4 is, so that's negative 16 plus 4, that's negative 12. Oh, sorry, that should have been negative earlier on as well, shouldn't it? So it's 2, negative 12. I suppose it's because all the powers are even. We get the same value either way, don't we? 2 or negative 2. So if I was to draw this graph, I know it's going to go through 0, 4. And that is going to be a maximum. So if I sketch that a little bit, negative 2, negative 12. So should we call this negative 2, negative 12? And draw a little bit of that. Negative 2, negative 12. What was this? 0, 4. And 2, negative 12. Well, let's call that up there. And that is another minimum. 2, negative 12. So I don't know how the rest of it goes, but I do know that that must go up there. That must come down there. So I assume that that goes off like that. Number 6. Y equals x cubed, take away 48x. Let's just work out the gradient. When that's 0, we've got 3x squared equals 48, x squared then equals 16, a nice square number, x equals plus or minus 4. Remember that a square root has two answers. Negative 4 squared is 16, 2. So we've got two values of x we need to investigate. We've got negative 4. We'll try 0 in the middle, and we'll try a number here. Let's pick, I don't know, negative 6. And this one will pick 6. So remember that that is your dy dx is 0. Oh, wrong one. 0. That is also a 0. Right, let's plug in 0 into our dy dx. 3 lots of 0 squared. Take away 48. 3 lots of 0 squared is 0, isn't it? So take away 48. That's a negative. The 6 one here, we do 3 lots of 6 squared, take away 48, which is 3 lots of 36. 36, 72, 108. So that's 60. Now, if I plug in negative 6 into this, because of the squared, it's still going to come up with positive 36. I know this is going to be positive as well. So your answers are positive, 0, negative, 0, positive. So it is going to go for your first three coordinates. Positive is 0, a negative. So positive, 0, negative, that is going to be a maximum. And the second three values, negative, 0, positive, negative, 0, positive, negative, 0, positive. That is a minimum. So let's find out our values. For this one, x was equal to -4, and for this one, x was equal to 4. Plug it into our original equation. X cubed, take away 48x. So y equals x cubed, take away 48x equals -4 cubed, take away 48, negative, lots of -4. -4 cubed is -64. -48 times -4, that would be 200. It's going to be positive, isn't it? 200, 192. No, 130, 128, isn't it? So our two answers, -4, 128. That's our maximum point. And for this one, y equals x cubed, take away 48x. That's going to be 64, take away 192. So that is going to be -128. So it's just these coordinates flipped round, isn't it? So if I was to draw this, we know that -4, 128 is a point. Now -4, 128 is a maximum. So it's going to be like that. And for -128, that's down here somewhere, in it. For -128, that's going to be a minimum. So it goes like that. I don't know how to draw this, but it's going to be something like that, isn't it? Question number 7. Y equals x cubed plus 6x squared, take away 36x plus 25. dy dx then equals 3x squared plus 12x, take away 36. Set that equal to 0, divide everything by 3. Factorise. Didn't divide that by 3 very well, did I? So it's going to be plus 6, and that's that factorised. So your two solutions are x equals -6 or x equals 2. Let's plug these into dy dx. So our values are -6, and we've got 2. So I'm going to put 0 in between them. I'll have -8 here. This one is 0. We know that's 0, and we'll call that 4. Plug that back into that formula there. So 0 squared, 12 lots of 0, that's all going to be 0, so this is going to come out as -36. for your dy and dx. This one, however, is going to be a bit more complicated. Right, negative 8 squared is 64. 64 times by 3 is 192. This is negative 96. Take away 36, so that's negative 120, negative 132, so that's just going to be 60 then. That's going to be left over. Important thing is it's positive, so we've got positive 0 and negative already. And then this one here, 4 dy dx, is 3 lots of 4 squared plus 12 lots of 4, take away 36, 3 lots of 16, 48, 12 lots of 4, 48, and 36, that's 60. Okay, so we've got positive, 0, negative, positive, 0, negative. So that's a maximum point, and for the next one, negative, 0, positive. So that's a minimum point, and that's where x is 2, and that's where x is negative 6. Right, we plug these numbers back into our equation with y, so it's this long thing here. So y equals x cubed plus 6x squared, take away 36x plus 25. So let's try and do this quite fast. Negative 216, negative 36 times 6 is negative 216. This is positive 216, sorry, that was meant to be plus, and that's 25. So that would cancel 0, so it's 216 plus 25, that's 241. So your answer is negative 6241 at that point. And then this one here, y equals 2, so x equals 2, so that is 2 cubed, 8, 6 lots of 2 squared, 24, 72, 25, 32 take away, 72 is negative 40, plus 25 is negative 15. So it's 2, negative 15. So your maximum point is at negative 6241. So let's do a little sketch of this. Nice and neat, obviously. Negative 6241, that's up here, and we know that that is a maximum point. So let's draw a little bit of a maximum. 2, negative 15, that is way down here. Okay, obviously not to scale, this being 241, this being minus 15, and that's a minimum point, it says up here. So it is going to go like that, something like that. And the last question, finally. Two x cubed take away 15x squared plus 24x plus 8. Differentiate. Now everything's in the 6 times table, so divide by 6. Please say it factorises. Now, x take away 4, x take away 1. Yeah, x equals 4, or x equals 1. So your values of x, your values of dy dx. So we're going to try 0. 1 we already know gives us a value of 0. Let's try 2. 4 we already know gives us a value of 0. Now let's try 5. So let's put this 0 back in. First of all, I get the impression this one's going to be easy. 6 lots of 0 squared is 0. Negative 30 lots of 0 is negative 30 is 0. This is 24. So it's going to be positive 24. 2 squared. 6 lots of 2 squared for this one. Plus, take away 30 lots of 2 plus 24. That's 6 lots of 4. That's 24. Negative 30 lots of 2 is negative 60 plus 24. So that's 48, take away 60. That is negative 12. And last one, this one here, 5. So that's 6 lots of 5 squared, take away 30. Lots of 5 plus 24. So 6 lots of 5 squared, 125 times 6, 150. Take away 150, that's going to be 0, plus 24, that is going to be 24. That worked out nice. So, nice and symmetrical there. So, first three values, positive, 0, negative. Positive, 0, negative. So that is a maximum. Remember that was at the point where x was 1, so I'll just write that down now. X equals 1. Next one, we had negative 0, positive. Negative 0, positive. That's a minimum point. So we've got x equal 4 there at that point. Right, we have to plug these numbers in, x is 1 and x is 4, into this formula back here. So y equals 2 lots of 1 cubed, take away 15 lots of 1 squared, plus 24 lots of 1, plus 8. So that is, what, 2 take away 15 plus 24 plus 8. Negative 13, positive 11, positive 19. So your solution there is 119. Y equals, on this one, 2 lots of 4 cubed, take away 15 lots of 4 squared, plus 24 lots of 4, plus 8. 2 lots of 4 cubed, 128. 15 lots of 4 squared, 15 lots of 16. That is 240. And that's 96, and that's 8. Right, let's add these together. 210, 224, 232. Take away that is negative 8. So your answer here is 4, negative 8. Right, let's draw this then. So you've got these two bits, 4, negative 8, that's going to be down there somewhere. And this one here, 119, that's going to be up here somewhere. And that's going to be the maximum, and the other one's going to be the minimum. So it's going to go through like that, and like that. Something like that, I reckon.